Hello and welcome to Console Cowboys. So if you haven't already, hop in the description below and follow me on Twitter to see the types of things that I'm putting out to keep yourself up to date. Also, I hope you enjoyed all of the reverse engineering content that we put out over the weekend. Hopefully you learned a lot about bytecode and how to make sense of it. Now we're going to get understanding on another important topic in blockchain, and that is signing transactions. So anytime we're going to send value across the Ethereum network, we're going to need to sign that transaction to authorize sending that value from our wallets. And we do that with our private keys. So we have public keys and we have private keys. Our public keys are our accounts where we hold our tokens and our value, etc. And our private keys are used to authorize any kinds of transactions and sign them. So we'll need to do that when we're manually attacking contracts. We'll have to sign those before we can run those transactions. So let's learn how to do that in Python so we can construct our attacks in Python and not be reliant on other tools or be reliant on our wallet signing it for us. We need to be able to do that at a low level ourselves. So let's hop into it. Firstly, we have our template right here. And the only difference between this template and the other one we've been using from our template.py is our template.py is using a mainnet Infura URL, and our template here is using a local ganache, which is running on our local network on 127.0.0.1 on port 7545. That is the only difference. The reason we're doing that is because now we're getting into making transactions that cost money and sending value, and we want to use fake Ethereum for that, so we're not spending money while we're doing our research and development. So in order to do that, you're going to need a local blockchain. Of course, you went through my last course, so you should be familiar with this, but I'll quickly show you this. You need to install Ganache. So you can do that at trufflesuite.com/Ganache. It'll give you that download for Windows, or if you're coming from another OS, it'll give you a download for that. So you can install that into Linux as well. Once you do that, it's going to look like this. Once you hit Quick Start Ethereum, it's going to open up a blockchain for you. Now in here, you're going to have your accounts. If you click the key, you're going to have your private key so you can sign transactions. You can also look at the transactions, etc. That's the way that looks. You can cruise around there and check out what's in there. If you're in Linux, we also have a couple other options. You can do this in Windows as well, but I generally do this in Linux. Is the command line. So we have our GUI we can grab, and that'll come back as this app image that you might have to do an execute bit at with, chmod -x. So once you do that, you should be able to launch this by double clicking it, or you can say npm install ganache CLI. Once you do that, it'll install that and you can run it at the command line. So if you say ganache CLI, it'll give you a no frills version without the UI, but it'll give you everything you need to follow this tutorial if you want to do this in Linux an easy way. The only difference is you're going to use 127.0.0.1 and you're going to use a different port, 8545. So make sure to update that within your script to 8545 if you're using that, or launch it with 7545. And up here, if you scroll up, you'll see your accounts, you'll see your private keys, and it'll post your transactions below. So with that out of the way, let's think about what do we need to do in here in order to send our transaction. So first we have to make our connection. So let's make sure our connection is actually working. We have our Ganache up and running. So let's connect to it. I'm going to hit terminal and we're going to run this. So I'm going to say Python signing transactions, and what we should get back is just that true again. Exactly. So the same as the mainnet. Nothing has changed. We got a true because we connected. So next up, what else do we need? Well, we need our accounts for our transactions. And then we need to build a transaction. And after that, we need to sign and send that transaction. So how do we do this? Well, we can grab our accounts for the transactions right out of Ganache because that's what we're using. We're using this first account to send a transaction, and we'll use the second one to receive it. So if we hit the show keys, we can grab our account and we can paste this in here and we'll say first account equals, and then after that we will say first account, and we'll call this PRIV for private key equals, and we'll grab that private key. So that'll be that one right under here. And now we need a second account because that's where we're going to send our value. So we'll say second account equals, and we'll grab that from Ganache as well. So you can copy it there, or you can hit here again and just grab it. So I'm going to paste that in here, and now we have all of our accounts. So we're going to send from our first account, sign that transaction with this private key, and then receive it at this second account. Perfect. So what do we need to do next? We need to build a transaction. So let's do that now. We're going to build this transaction with a transaction object that we create. And we're going to need a few items in here. So in order to send a transaction, we're going to need a nonce value, which is unique for each transaction. We're going to need the account that we're sending the value to, which is our second account. We're going to need the amount of value that we want to send, in this case, 1 Ethereum. Then we're going to need the gas, and we're going to need the gas price. So let's start with the nonce. For this, we need a unique value. So we're going to use Web3, and we're going to use the transaction count for that account. So we'll say get transaction count. And that gets the amount of transactions this account has sent. And we can see that within Ganache. So since we haven't sent any transactions, we have a transaction count of 0. But after we send 1, it'll be 1, then 2, then 3, etc., which makes it a decent unique value for us to use for this. Next, we need the to value. So the to value is going to be our second account. That's where we're going to send value to. And how much are we going to send? Well, for the value, which is that message.value in Solidity, we're going to say web3.toWay. So this is the opposite of what we did last week, where we converted from Way to Ethereum. Now we're going to say 1 Ether, and we're going to take that 1 Ether. Instead of putting those 18 zeros after there, we're just going to say convert 1 Ether to Way for us so we can send it over the blockchain. These different utilities just make our life easier so we don't have to deal with those longer numbers, and 1 Ethereum is easier to view and type out. So next up, we're going to say gas. Well, we need to send the gas limit here. And what I'm going to do is I'm just going to steal the one that Remix uses because we know it works. So I'll just say, grab this number here. This is our gas limit. And we're just going to paste that into our code. And that should work just fine. Now we have the gas price. Now gas price is one of those things that are always fluctuating. You'll notice some days you go out there and you make a transaction on Uniswap and it's like $1. Other days it's like $250. And these fluctuate based on how much activity there is on the network. So we can grab these in a few places. We're going to use Web3 here and say Web3 to Way again. And we're going to put a value in here. Now, how do we know what value needs to go in here? There are a few places we can check if we are on mainnet. So we can go in here and say, go to something like etherscan.io gas tracker and look at the current Way. So it's saying low would be 18 Gwei and high would be 19 Gwei. So if we were front running a contract and trying to get in front of a transaction, we could put a higher value, get in front of that transaction, and then put a lower value and sell that transaction after the regular user and then attack them that way, because the more put in there, the quicker our transaction is going to happen, and the lower, the longer it's going to take. So it allows us to manipulate how fast our transactions are going on the network and use it for front running and sandwich attacks. So in this case, it's saying, okay, 20 Gwei should get us there if we want to send it fast. That's on the mainnet, obviously. We're local, but we can just use that value anyway. So we will say 20, and we're going to use the value Gwei. And then we're going to convert that Gwei down into Way. That way we can send it over, and it's the way that the network understands it. One thing I forgot to mention, so I'll just insert it here real quick while I'm editing. You can also use ETH.gasPrice or the updated ETH dot underscore gas price when you're coding this, and it will grab it for you and you can put it right into your transaction just as another option. Once we create that transaction object, the next thing we need to do is we need to sign and send that transaction. So let's do that now. If you think about it, this is actually really easy to do. All we have to do is we have to take our transaction that we created and we need to sign it. Once we sign it, we send it. So how do we do that? Well, we'll create a signed transaction. So that's what we're going to call our variable. Signed transaction. And we will make that equal to web3.eth.sign transaction. Pretty self-explanatory. So what are we going to sign? Well, we need our transaction we created up there. And then we need our private key to actually sign it with. So first, account priv. So pretty self-explanatory. We can just say, okay, we want to sign this transaction. Here's our transaction. Here's our private key. Let's sign it and put it in a variable called signed transaction. Now we have a signed transaction to use. Pretty simple. So what do we have to do next? Well, we have to send that transaction, correct? And it's going to give us back a transaction hash. So let's say transaction underscore hash, and we want that to equal web3.eth.send raw transaction. And what are we going to send? Well, we're going to send our signed transaction, right? So we'll put that in there and we'll say dot raw transaction. And that's all we need to do. Once we do that, we will get back our transaction hash. Perfect. So let's view what our transaction hash looks like. So we'll say print, and we want to put in our transaction hash. But we want to get this back in hex because all of these values are always in hex when we're viewing them. So that's the standard way that we view them. So let's do that. We'll say web3.to hex. And you saw this the other day when we were converting our bytecode and then analyzing it. So you're familiar with that. And we should now get back our transaction hash. So let's take a look at that. Enter. And what should happen now is we got some kind of error here. And that's because we forgot account here. So it is eth.account.sign transaction, and that should work just fine. So let's give that a try now. And if you read that, across, that makes sense, right? We're going to say Web3, we want our account to sign that transaction, and we want to use our private key to sign that transaction. So it all makes sense just by reading it. So now let's do that, and we get back connected true, and here is our transaction hash. Perfect. So if we look at Ganache, we will see we now have a transaction account of 1. We have a balance of 99 because we sent one out to account number 2, which now has a 101. So we were able to successfully create a raw transaction right here. And then once we created this raw transaction, we were able to sign that transaction ourselves and then send it over and get our transaction hash back. And then we printed out our transaction hash. So that's perfect. So what else can we do with this? Well, we can also get our transaction details as well. So we can just say print web3.eth.get transaction. And within here, all we have to do is pass it our transaction hash, and it will grab the details of that transaction. So let's do that. And we see everything come back. So we have our from address, we have our to address, we have our value here with all 18 zeros on it after we converted it to weigh. We see our gas price, etc. So that's how we can view the transaction with the transaction hash. And then you can also do all of this stuff within here too. So you can see your transactions in here and see what's going on. And yeah, so that's it as far as that goes. So now you're able to send transactions manually with Python, which allows you to now manually connect to smart contracts, run functions, make changes, and hack things without having to rely on other people's tools or use JavaScript. you're able to just hop in there with Python and do all these things manually. So this is going to greatly help you when you're trying to play around and hack around on things. And now we're going to take all of this knowledge and use it to attack our bank contract, make withdrawals. We will do deposits. We will hack around on it, pull storage values, etc. And we're going to do all of that with Python, but now we can sign those transactions when needed. So hopefully you learned something. If you did, like the video and share this out on social media and leave me a comment below. I greatly appreciate it, and the YouTube algorithm greatly appreciates it. So I will catch you later. Thank you.